kids. Today we are going to talk about theoretical probability, which just means we're going to make a prediction based on what we think might happen. So let's take a look at the definition of theoretical probability. Now, this is not what it would say in a textbook. This is my definition. And probability we write as a fraction. It actually can also be written as a percentage or a decimal, but we're just dealing with fractions here. And the way I write the fraction for theoretical probability is my numerator is this, the number of ways I can get what I want. And the denominator will be the number of things that can happen. And that can also be thought of as the number of items in the sample space. Let's actually write that in. Number of items in the sample space. And that's just a list of all the things that can happen. So let's take a look at one of the tree diagrams we did together yesterday. Let's see. So this was one of them. Remember, this is again the sandwich tree diagram. I make sure you can see that. Where we were choosing greens for our sandwich, lettuce or spinach, and then an additional topping, sprouts, avocado, carrot, sprouts, avocado, carrots. And we counted each of the branches on the tree, and we understood that those were each a different combination. So, keeping in mind our definition, that theoretical probability is the number of ways I can get what I want over either the number of things that can happen or the number of items in the sample space. So here was our original directions, that we were choosing lettuce or spinach and that we were then choosing sprouts, avocado, or carrot. So let's take a look at this down here. What is the probability of getting spinach and sprouts? Well, let's see. We need to figure out how many ways can I get what I want. So I'm looking for all the combinations that include spinach and sprouts. Let's see. Well, it can't be any of the lettuce combos. So let's look over here. Spinach and sprouts. There's one. There's a spinach and sprouts right there. Spinach, avocado, spinach, carrots. So there's only one way we can get what we want for getting spinach and sprouts. So the numerator is 1. And since there are 6 combinations, the theoretical probability that you get the sandwich that has the spinach and the sprouts is 1 out of 6. One way I could get what I wanted, 6 items in the sample space. Let's look at this one. What is the probability of carrots? So we're looking for all the combination that have carrots in them. And I think I'll use my orange highlighter for this one. And let's see, lettuce, sprouts, avocado. So we're looking for the probability of carrots. Well, here's one that has carrots. Sprouts, avocado. There's one that has carrots as well. So how many of these combinations can we get what we want? 1, 2. So there are 2 ways to get what I want out of the total of 6 combinations. So the probability of getting carrots is 2 out of 6. And we can simplify this fraction by dividing top and bottom by 2 over 2. 2 divided by 2 is 1. And 6 divided by 2 is 3. So the probability that we get carrots is 1 out of 3. Terrific. Let's look at the second sample we did yesterday. And here it is. So our original directions, let's see if I can move that up a little. Our original directions said to choose a backpack, a tote, or a string pack, and to choose an iPad or a book. And we found that we had 6 combinations again. So let's figure out some of this probability. What is the probability of selecting a tote and the iPad? So we're looking for the combinations that include tote and iPad. Can't be in this section, that's a backpack. Can't be in this section because that's the string pack. So here's where we can choose a tote, and this is the only place that we can choose the tote and the iPad. So right here is the one branch that shows that there is one way of getting what we want, the tote or the iPad. So our numerator is 1, and our denominator, remember that the denominator is the number of things that can happen, or the number of items in the sample space, and that was 1, 2, 3, 4, 5, 6. There we go. So the probability of getting the tote and the iPad is 1 out of 6. What's the probability that you get the backpack? Well, let's take a look. Obviously no backpacks here or here, but this combination has a backpack, and this combination has a backpack. So there were 2 ways we could get what we wanted. 2 ways that we could get that backpack. So it's 2 out of total number of combos, 1, 2, 3, 4, 5, 6. And again, 2 over 6 can be simplified to 1/3. Probability, theoretical probability. All right, let's look at some different tree diagrams that we did yesterday. Here's one that we did about sandwiches. And again, we're going to be looking for the number of ways I can get what I want, that's my numerator, over the number of things that can happen. That's the denominator. And again, you can think of that as the number of items in the sample space. So let's see. This was the original direction that you were going to choose a wrap, a pita, or a roll. And then you were going to choose tofu, cheese, or veggies. So let's take a look here. What's the probability we choose pita? And let me go ahead and highlight our pita choices, our pita combos. Can't be here, that's all wraps. So here are the pita choices. And obviously not with the roll. So there is what I do with my pen. So how many ways can we get what we want? If we're looking for pita, there are 3 ways to get what we want out of how many combinations? Remember, you can just count those branches. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 combinations. So we have 3 over 9. And we can simplify this fraction by dividing top and bottom by 3 over 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So the simplified theoretical probability of getting pita is 1 out of 3. Let's look at this one. So what's the probability that we get a roll with vegetables? Let's see. No rolls here, no rolls here, and a roll, tofu, cheese, vegetables. It is only this one right here. Only that branch includes a roll and vegetables. So the number of ways we can get what we want is 1 out of, and remember there are 9 combinations. So if all 9 sandwiches are on the table and you randomly choose one, there's a 1 in 9 chance that you get the roll with the veggies on it. All right, one more. So here's our beach day one. And just as a reminder, because we have a lot of abbreviations on here, that it was surfing, boogie boarding, or kite flying. So those were the activities that you had. Then you were choosing the time of day you were going to go. So I actually have that written down here. So morning, lunch, afternoon, or evening. Or you could boogie board in the morning, lunch, afternoon, evening, and so on. So what is the probability of going surfing in the evening? Well, let's take a look. Here's all the surfing combinations. And just this one branch shows surfing in the evening. So there's only one way we can get what we want out of 12 combinations. So the probability of surfing in the evening is 1 out of 12. One way we can get what we want out of 12 items in the sample space. All right, last question. What is the probability that we go in the morning or the evening? So let's see. Here's a morning combo, and there's an evening combo. Here's a morning combo and an evening combo. Kite flying in the morning or kite flying in the evening. So let's see. We've got 1, 2, 3, 4, 5, 6 branches. 6 ways I can get what I want out of the total of 12. And 6 out of 12, if I divide top and bottom by 6 over 6, 6 divided by 6 is 1. 12 divided by 6 is 2. So the probability that I choose to go in the morning or the evening is 1/2. Okay, so I want to give you your independent work. I'm going to be the first to admit that this is challenging, but I know that you can do it because we've practiced each of these skills separately pretty extensively, I think. So there are 2 directions on your independent work for today. First thing you're going to do is make a tree diagram. The second thing you're going to do is find the probabilities that I'm asking you about. So let's read the problem together. Getting to school. You have the choice of getting a ride or riding the bus. Okay, so it's ride or bus. Then you have the choice of listening to music, doing homework, staring out the window, or talking. Okay, so choice of listening to music, homework, window, or talking. So there were 4 possibilities for your activity. 2 choices for your transportation, 4 choices for your activity while you're riding. And then you're going to find these probabilities. So you make the tree diagram first. Give yourself lots of room, just like we did on all our tree diagrams. Then you're ready to find probabilities using this definition for your fraction each time. Number of ways I can get what I want over either the number of things that can happen, or you can think of that as the number of items in the sample space. So you can do this. You can definitely do this. You've been doing beautifully with all of this remote learning, and even though this one's a little more challenging, I know you're going to step up and really do a great job with it. Take care, kids.